Good morning, good evening, knowledge seekers and executors. Today I'm going to talk about creating the microservices design patterns, how the design patterns has been helpful when you are developing the microservices. So let's go on that. So before going that, how the design patterns will be helpful for the microservices and what is microservices. So simple, building software today often feel like designing a metropolitan city. Each part has its specific role: homes for living, roads for commuting, and park for relaxation. Similarly, in microservice architecture, each service handles one particular responsibility. But how do you maintain coherence among these pieces without causing confusion? There you have the microservice design pattern, which has been proven solution for challenges in building distributed systems. So there are 5 essential microservice design patterns, which has been explained. I'm going to explain with the relatable examples to making learning effortless. The first one, aggregator pattern, bringing it all together. So aggregator means bringing all together. So what it solves, combines responses from each microservices into one. So consider one example, one use case, creating a single API endpoint for complex queries, like fetching customer profile from multiple sources. Example, imagine ordering a pizza meal. You want the pizza, a drink, and the dessert. Instead of placing separate orders, you receive everything together seamlessly. That is what the aggregator pattern. So how it helps? This pattern ensures data from various services is gathered and presented as a unified response. So aggregator pattern is combination of all the patterns into one. The response will come to you. Then the next one, saga pattern, keeping things in sync. That is what the saga pattern. Everything will be in sync. What it solves, coordinates tasks across service to maintain consistency. So again, it talks about sync and the consistency. We'll give a classic use case, coordinating a multi-step process like ordering creation, payment, inventory, updates across services. Example. So think of a planning. For example, think of a planning a vacation. You book a flight, reserve a hotel, and rent a car. If the flight gets cancelled, the hotel and car bookings are cancelled too, ensuring no disruption. So that is what the saga pattern. So in simple terms, consistency and sync. So this pattern allows each service to function independently while ensuring overall integration and consistency. The third one, API gateway pattern. So your system's receptionist, your system's receptionist. That is what the API gateway. What it solves, acts as single entry point for user request. So it's like, if you go to any hotel or any place, so the receptionist is the one resolving all that problems. It's like front desk, right? That is what it is, the API gateway. Perfect for handle requests across a mobile phone, web phone, and third-party integrations. For example, imagine a hotel lobby where the receptionist directs you different services, room keys, restaurant bookings, taxes. How it helps? An API gateway simplifies communication by routing all user requests to the right microservices and managing security and authentication. The strangler pattern, that is what the fourth one, the strangler fig pattern. It says it's a gentle upgrade. So it's always upgrading things. Gradually replaces old system with modern microservices. That is what the solution, which has been provided with the strangle fig pattern. Use cases, gradually replacing legacy components while keeping the system functional. So it is not like, take out everything and slowly building. It is as simple as it lift and shift. So you lift that old one slowly, one by one, brick by brick, and replacing with the upgraded version. So take it, for example, a renovation. Instead of demolishing whole building, you upgrade one section at a time while keeping it unstable. while keeping it usable. How it helps? This pattern supports incremental transformation, minimizing disruption while upgrading a modern system. The fifth one, very important, circuit battery pattern. So it is avoiding overloads. So basically, it prevents cascading failures in case of service overload. The classic use case is protecting your application from being overwhelmed by retry storms. For example, your house circuit breaker, as simple as it is. If too many devices are used, it trips to protect your appliances. The pattern safeguards your application from being overwhelmed by failures, ensuring reliability and user satisfaction. So just imagine, without these patterns, microservices can turn into a traffic jam of errors and confusion. These patterns keeps system running smoothly, handle failures gracefully, make it easier to build and grow. So the summary is, microservices might sound technical, but they're all about solving real-life problems in a digital world. From ordering pizza to planning vacations, the concepts are closer to everyday life than you think. Thank you.